Welcome, my dear students. This class. In the last class, we discussed about the solve the system of linear equation by the method of a inverse of a matrix. If A is invertible, then there exists a matrix C. So again, we can show that this A X can be written as a inverse into B. And also we prove some results. That means we have to some equivalent condition. If A is invertible, then if the system is homogeneous, then only the trivial solution are exist there, and also some other conditions also. In this class, we discuss about the some applications of a linear system. We have to discuss so many classes devoted to the study the how to get the solution of a linear system. And now in this class, I just emphasizes on to the take some 2-3 problems of the other branches and try to solve to these problems with the help of this system of equations. So that means you know that idea how to application of this linear system of equations. We have to study lots. We have to spend many lectures on the solving the linear system of equation by various method. One of the method is a Gauss elimination method. Another is a Gauss-Jordan method. Another is a we have an inverse method. So all this method and row reduced echelon form is also. So we just try in this lecture concentrate on about the application. Let's start with the first is a network analysis using the linear system. So network analysis is this means a network with the 4 nodes are there. We have a this is a 1, 2, 3 and 4 nodes are there. Has a certain known flow rates and direction. So we have a certain known flow rates and direction is there. Now the objective is to find the flow rates and the direction of the remaining branches. So we have to just take a we going to this, we have to write the flow rates and the directions in the remaining branches of these other branches of this flow. Okay, just start with the we can assign some value and the direction, because this is coming to this direction, so this is going to this direction to this, and this is coming to this direction is again this to going to this, this is going to this way and this way. So we have a like this. So we just take this this I have to just assign some direction is accordingly this. So we have a this and this, so we have to just state this is equal to we have a x1 and this we have a x2, then we have x3. This is already we have a giving is a 15. This 3 is not giving, so I just put x1 here, x2 here and x3 here. So this is I giving the some variables x1, x2, x3. And now figure we have assigned the arbitrary directions of unknown rates flow x1, x2, x3. We need to be concerned if the same some of the direction are incorrect, since incorrect direction will be signed by the negative value. If we have a direction is incorrect, then we can just say that whatever value we have to getting is the negative value of the flow rate. Then we solve to the we have to try to find the unknowns. So we just write the first equation. We have a we can write x1 plus x2 is a flow rate is equal to 30. So we can write x1 plus x2 is equal to 30 by the by that this by node A. So we have a x1 plus x2 is equal to node 30. Then x2 plus x3 is equal to we have a 35. So x2 plus x3 is equal to we have a 35 for node B. And now we have a x3 plus 15 is equal to x3 plus 15 is equal to we have a 60. So x3 plus 15 is equal to we have to just say that 60 for node C. And then we have to this x1 plus 15 is equal to 55 for node D. So we have to just set x1 plus 55 is equal to node D. Now this is clearly you can say that for node D x3 is equal to you can write is a 60 minus 15, and node C is equal to you have node D can be written as x1 is equal to you have a 55 minus 15, and then this means we can write the system of equation in the form of this x1 plus x2. We have a 3 variables x1, x2, x3. So we write this equation in the form of a system of equation. So if write in the system of equation form, this is x1 plus x2 is equal to 30, and then we have a second with x2, x3 is equal to x2 plus x 35. Now we simplify this. You have a, this is equal to you have a 45, and this is equal to you have a 40. So this means we can say that this is equal to x3 is equal to 45, x1 is equal to you have a 40. Now if you have x1, x3 you have a value, so we can calculate directly substituting the value, because no need of any other this. So we have a x1 is equal to you have a sorry x1 we can x2 can be written from first equation. We can calculate easily is equal to x2. X2 is equal to you have a 30 minus x1, and x1 is equal to you have a 40. So 30 minus 40 is equal to you have a minus 10. And from the second equation we calculate the x3. X3 is equal to you have a 35 minus x2, and this can be written as a you have a 35 minus x2 is you have a x2 you have to calculating already is a minus 10. So this is equal to 35 plus 10 is equal to you have a 45. So we getting the value for x1 is equal to we have a minus sorry, x1 is equal to you have a 40, x2 is equal to you have a minus 10, because now minus 10 means we have to direction of the flow is opposite. Minus means is saying that we have to, in the beginning we have to assuming that the flow of this dimension is clearly is opposite, and then we have to x3 is equal to you have a clearly is a 45. Okay, just like this. So we have to simplify this, we have to getting this. These are the things. X2 is negative, tell us the direction originally assigned to the figure is incorrect. That means whatever direction we have to assign here, x2 means this is assigned, we have to this direction is assigned is correct. This should be we have to just say that this is the this way direction. So this means we can say that but this direction is correct, and assigned direction is this is also is correct. So this means we can say that simply is incorrect, that is the flow in the branch of is actually into a node A. So this means is actually flow in the branch is actually is into a node A, not A to B. This is going to a node of A in this form. We have to flow of this transformation is going to a towards the A node of A. So this this way we can say that this way we can complete the solution of this application. So this way we can calculate the any flow, and then we can assign some variables, and then we can write equations, and then we can merge for a system of equation and then solve the system equation. We know that various method of solving the system equation, either Gauss elimination method, Gauss-Jordan elimination method, or inverse method, and any Roeder's Eklund form, whatever this. So by this we getting the solution of this. Okay, let's move to the next problem. It's some interesting problem. I just check. We take a design of a traffic patterns. So this means we have to just say that we have a Library Park Street, 6th Street, 5th Street, Market Street, and Kensington Street, and then we have a traffic red light. This is we have a traffic red light is here. So I just take a the network in the figure is show proposed plan for the traffic flow around the park, and that will house in the Liberty Bell and Finlandia Peninsula. This is this problem from the book of Hongs. So this is a problem already in the book. This I just take from the book. This problem. So the plan calls for a computerized traffic light at the north exit. So this is north exist on the 5th Street. This is the street in the 5th Street, and the diagram indicates the average number of vehicles per hour. This is showing that average number of per hours is going to this direction. 500 from this to marketplace to is in direction 500. This leaving this is equal to this form. So this is number is showing that is the per hour expected flow in and out the streets that border to the complex. All streets are a one way. So all the streets are the one way. There's no other way traffic is going on. So now the problem is this: how many vehicles per hour should the traffic light let through to ensure that the average number of vehicles per hour flowing into the complex is the same as the average number of vehicles flow out. Another question is assuming the traffic light has been set the balance the total flow in and out of the complex, what can you say about the average number of vehicles per hour that flow along the street and the border of the complex? Okay, we can just try to, this is a figure, and then we have to just in this figure we assign values for x1, x2, x3, and x4, and all these 4 streets are this thing. So x denote the number of vehicles per hour and the traffic light must let through, and then the total number of vehicles per hour in flow and outflow complex will be. We can calculating this. So this means we can just 600. This is we have to denote it x is a x as a traffic light. So this how many element is this? So we can just take you just take a we have to take into the form of a flowing in. So flowing in, you have a just flowing in is this direction is a 500. Then you have a flowing in, you have a 500, and then you also is a 200. Then you have a 600, and then you have also the 400. So flowing in, you have a 500, 200, 400, and 600 and 400. So we can say that 500, 400, 600, and 200. Then we can say that this total flowing into the red light area, you have to just say this is this way into this node B. Then we can say that this is equal to 500. You have a 200, 600, and 400. This is a 1700, and flowing out is from the x. X is the this is flowing out from x, and then we have a flowing out is a 400. Then we have a flowing out is a 700. So we can say that we have a this is equal to x, 700, and 400 are the flowing out. So equating the flow in and out show the traffic light should be x is equal to, you have a by these two equations. We can simplify this. So by this we can say that this is total. So we can say that x plus you have a 1100. 7 from this is equal to, you have a sorry, this is 1100 is equal to, you have a 1700. Then x is equal to, you have a 1700 minus 1100 is equal to, you have a 600. So this is per vehicle pass through. This means we can say that by this we can say that the flow in out shadow the traffic light should be x is equal to 600 vehicles per hour pass through this according to this thing. Okay, so now we have to avoid the traffic conjunction to flow and must equal to flow section. We have to intersection A, B, C, D. So we have to just say that intersection A, B, C, D. So we just write, and then flow in 600 the intersection of A. Just check the flow in. We have a 600 and 400. So you have a 1000, and this is flow in. You have a this is coming to this 500 plus 2. Then we can say that B is equal to, we can say that clearly B is equal to, you have a x2 and x3. So this means x2 and x3, and C is equal to 200 and plus 500, and D is equal to, you have a x4 and so on. Okay, so now we have to just set x1 plus x4, and then you have a x1 and plus x4 is this way. So this means we have a flow in, this is equal to this, and then this is B, and C and D is equal to this. Then similarly we can write for a flow out for A. If you take a flow out of A flow out this direction and this direction. So you have a x1 plus x2. For this is flow out is equal to x3, and then you have x4, x3 plus x4. D is flow out, you have a this is equal to 700, and then we have a only these things. Okay, so this means we can say that clearly x1 plus this is only 700, and this way. So this means we can construct this right in the form of a system of equation. So x1 plus x2, you have to x1 plus x2 is equal to 1000. Then x plus 400 is equal to, we can say that this x2 plus x3 is equal to, you have a into 1000, and then x3, because x is already, we have to calculate value for x is equal to we have a 600. So 600 plus 400 1000. That's his reason is this is 1000 is coming from, you have a 400 plus x is equal to, you have a 400 plus you have a 600, that is equal to. Now next is equal x3 plus x4 is equal to 700, and then we have a x1 plus x4 is equal to, we have a 700. Now we have a 1 2 3 4 system equation, and then we have a 4 of the this equation. Then we have a maybe the solution is exists, and then we try to how to find the solution of this. This means we can say that if you take any two elements, you can just from these two you can eliminate this x4, then you can x1 and x3, and then x2 eliminate this. So first one we can just try to x1 plus x2 is equal to, we have a 1000. Now we have a x2 plus I just write into this. Okay, this is equal to 1000, and then we have a x2 plus x3, you have again is equal to 1000, and you take a subtraction, this x2 is a cancel out. So x1 minus x3 is equal to, you have a 0. So then we can say that x1 is equal to, you have a x3. Now if we have these two conditions, we can say that we have a x3 plus x4 is equal to 700. Now we have a x1 minus x1 this is x1 plus x4 is equal to, you have a 700. Then you have a subtracting these two, then you can say that x1 plus x3 is equal to, you have a this is x1 the x3, okay, x1 plus x3 is also 0. Then we have x1 is simply, you can say that this form. So this means this is clearly, we have a x1 is equal to this is x1 can be written in the form of a 1000 minus ka x2. Then x2 can be written, x3 can be written as a x3 can be written in the form of a 1000 minus ka x2. Then we can say that x1 and x3 is equal to the same, and then similarly we can say that x1 and x3 are the same. Now we calculate the x1 x3 are the same, then we can say calculate the x4 is equal to, you have a 700 minus ka x3, and then we can just say that into similar. So this we can say that 700 and 300 plus t, and then 700 minus t, and then x4 is equal to t. So we just substitute the value for x4 is equal to t, then we can getting from here, and then we can getting all the substitute. You can just take a elementary, just you have a 1. If you take a write in the form of a matrix form, it's we have a 1 0 x1 is equal to 1 1 0 0. Now you have a 0 1 0. Now you have a 0 0 1 1. Then you have a 1 0 0 1 and this form, and then we can just write in the 1000 700, and now you just check here, you have to make a by this minus 2, and then you can just this getting this system. You can just write this form in the form of a 1 1 0 0. Then you have a 0 1 1 0. Then you have a 0 0 1 1. Then you have to just subtracting these two, you have a 0, you have a 0 minus 1, then you have a 0, then 1 minus 1 is equal to 0. Now with the help of this, you can take a this again. So adding these two, you getting the last row is by the help of this, you can getting is equal to 0 0, and you have a 1, and then you have a 1, and then we have to move to the next step is here, and then by the help of this is 0 and this is 0, and then we try to this, then we getting the by the Gauss elimination, Gauss-Jordan deduction, we can write x1 is equal to this, x2 is equal to this, and x3 is equal to t. So because the streets are one way, all average rate flow must be non-negative. So this means all are negative, must mean x1 greater than equal to 0, x2, x3 all are good, must be condition is there. There is no negative values for this. So t should be the we have to choosing in such a way that t this all the values should be greater. This means more than 700. We can choose a t is a t is clearly is greater than or equal to 700, not less than 700. So this means 700 might be greater than this. So this means t is lies between 0 to 700. Clearly t is greater than 0 and less than 7. This is combining the inequality. The subparameter expression is this is formed. So x1 is like this, x2 like this, and x3 and so on. And the system has infinitely many physical valid solution. These bounds is there. So this way we complete the solution of this complete of this flow of this traffic into this by using the system of equation. Now one more example I try to for the chemistry. So this balancing the chemical equation using the linear system. Balancing chemical equation means we have a HCl and Na2PO4. This is the we have a one chemical equations are there, and we have to try to the balancing solution. So let v1 2 3 4 are there. So we have x1 x2 x3 are the positive integer coefficient, so that x into x1 into this plus x2 into this plus x3 into this plus x4 is equal to, we have to write this equation into write into this form. Okay, so this means equating the number of atom each component the both side. We have h is equal to, we have a 3, so we just write h is equal to x1 is equal to, we have a 3x, so h is here is a 3, so x1 is equal to 3x, so x1 is equal to, we can say 3 of x3. And now c is here, you have a x4, so x1 is equal to, you have a x4, similarly like this. So cl x1 is equal to x4, na is equal to 3 times of a x2, and na is equal to 4 x4, so we just write into this form, na is equal to 3x2 is equal to x4. Here we can just say po at 4x2 and po is x3, so we just stated that p x2 x3 and 4 x4 x3, and then we can just say that this is not different. So we just write into this form and substituting the each of the equating the number of atoms of each elements on the both sides, this giving to this form. So this equation in the, if we write in the equation of this form, x1 minus ka we can just say minus ka 3x3 is equal to 0, then x1 minus ka we can say that x4 is equal to 0, then we have a 3x2 minus ka x4 is equal to 0, then we have a x2 minus x3 is equal to 0, then we have equation is equal to, we have a 4 times x2 minus ka 4x3 is equal to 0. So this means we can write into this form. Now we write in the form of a coefficient matrix of this into this form. Argumented matrix, I will omitted the 0 column. Now we try to convert this into the form of a elementary row operation. By apply the elementary row operation, we try to transform into this matrix into the form of a row reduced echelon form. Apply this, we getting into this form, and now you can just say that this is we can set case right in the form of a this is last equation is equal to 0, and so this x1 x2 x3, and so means we can say that x3 minus 1 by 3 x4 is equal to 0. This means we can say that x3 can be written as a 1 by 3 x4, and then we have a clearly we can say that we have a x2 minus 1 by 3 x4 is equal to 0, then x2 is equal to also 1 by 3 x4, then you have a x1 minus x4 is equal to 0, then x1 is equal to, you have minus x4. So this means x4 are the free variables. X4 is equal to, we have to take a t, then x1 is equal to, you have a minus t, then x2 is equal to, you have a minus 1 by 3t, and then so on like this. So we have to just say that x1 is equal to t, x2 is equal to t by 3, x3 is equal to t by 3, x4 is equal to also t. Then we can say that t is equal to, you have a this thing. So this is okay, this is equal to minus 1. So this is x1 is equal to x4. Okay, so we getting this solution. Now obtain the smallest positive integer for the this smaller positive integer. If t is equal to 3, we getting the smallest positive integer. So x1 is equal to 3, x2 is equal to 1, then x3 is equal to 1, x4 is equal to, we have to getting 4. So balancing chemical equation is into this form. This way we can just complete this solution of a application of this system of equation by using the how to balancing the equation. We can, I just write you in the system of equation, we using also balancing the chemical equation, also use the application of this system of linear system of equation. Okay, now I just take one more example, that is the phenomenal interpolae by the Gauss-Jordan elimination. We can try to find cube polynomials whose graphs passing through the points. So this we have these are the points. If you just take a graphical point of view, just take, you have a 1 comma 3, so you have a somewhere x is equal to, you have a 1, then y is equal to 3 is here, then x is equal to, you have a 2, then x is equal to 2, then y is equal to, you have a minus 2. Okay, and then we have a x is equal to, you have a 3, and then you have a y is equal to somewhere minus 5, then x is equal to, you have a 4, and y is equal to 0. So like this you have a, then we go in this way. This is the flow. We have to just say the polynomial whose graph passing through this like this. We have a point. So this is a point. We have to passing through this point. So there are 4 points. We will use interpolation polynomials of a degree n is equal to 3. So px can be written in the form of a a naught, a1x, a2x square, and a3x cube. And then giving data, we can say that x1 is equal to 1, x2 is equal to, you have a 2, this is x1, and this is x2, this is x3, this is x4, this is y1, y2, y3, and y4. So this means we can say that substitute the coordinate of a px. We have a naught, a1x, ax2, so we have to substitute a1 1, a2 1 square, and 3, this is equal to 3. Though this is equal to for x1, a p of x1, we can calculate the p of x2. So p of x2 is equal to a1 2, and so on, and then p of x3 is equal to in this form, and then we write this into the form of a argumented matrix. So this is, you have an argumented matrix into this form. So this is equal to 1, this is coefficient 1 1 1, then you have a 1 2 3, then you have a 1 4 9 and 16, then you have a 1 8, and then you have 27 and the 64. And now apply for elementary row operation. For this we have to, with the help of this is a key element, make here a 0 and apply the row reduction form. After applying the row reduction form, this convert into this form, and now you clearly say that this is equal to x1, x2, x3, x4. So we're getting the value for x1 is equal to this, x2 is equal to this, x3 is equal to this. So this means we can say that the point of this can be written, the polynomial is nothing but a naught is equal to, you have a 4, a1 is equal to, clearly a naught is equal to 4, a1 is equal to 3, a2 is equal to minus 5, 4 is equal to, you have a 1. So this means we can say that, so px is equal to Polluting polynomial should be 4x plus 3x minus 5x square plus 3, and this graph passing through the, this is the polynomial passing through the points in this, we can get into this form. Okay, so this way we can just complete the solution of this problem also. So that way we can just say that clearly we can find some application in the try to find in the different branches of except mathematics by how to use this linear system of linear equation in the other branches also. So we try to find in the interpolation polynomials problem. We also discuss the problem for traffic red lights, one problem we can consider. We also for how to balancing the chemical problems, we can also use the networks analysis of this problem. So this all this I have to stop today's class at this point, and this I have to cover all the portion of this for a system of linear equations. We take so many classes for this because of this is a very important topic, and also we discuss various way of method for discussing for solving the problems, and also to concentrate many problems on this, try to solving this. In the end we also give the some applications point of view. That means we can use the system of equation application in the all the different branches for solving some problems also. So this all for this today's class. Thank you very much. In the next class we start about the eigenvalues and eigenvectors for the next class. So thank you for this all.